All right, y'all, this week we're going to take a look at complex numbers. Today we're going to kind of intro it and look at adding and subtracting and simplifying. Tomorrow we'll get into multiplying and dividing. So a complex number consists of a real unit and an imaginary unit. The imaginary unit is going to have the I involved in it, and the real unit is just going to be a number. So when you look at this, what is I? I is equal to the square root of -1. It allows us to take the square root of a negative number. So what is I squared? I squared, if I take the square root of -1 and multiply it and I square it, I didn't mean to erase it. So I got the square root of -1, I'm going to square it. So that is equal to -1. So that is the biggest, most important thing. I squared is equal to -1. Never forget that. So when we're looking at this table, kind of notice a pattern. I to the 0 power, anything to the 0 power is equal to 1. I is equal to the square root of -1, which is I. I squared is equal to -1. I cubed is equal to I squared times I to the first. So -1 times I is -I. I to the fourth is equal to I squared times I squared, so that is always equal to 1. I to the fifth is I to the fourth times I, so that is just equal to I. You start seeing a pattern emerging. I to the fourth times I squared. So I to the fourth is 1, so that always cancels out. So I squared is -1. I to the fourth times I to the third, so the I to the fourth cancels out. That's a 1. I to the third is -I, so on and so forth. It's a circular pattern with 4. So if we look at this, I if the remainder is 1, your calculator will say 0.25. It's got a remainder of 1, it's just I. -1 if the remainder is 2, so the calculator will say 0.5, so on and so forth. -I if the remainder is 3. And then 1 if the remainder is 0. So what we have here, -3. I to the 12th, if I do 12 divided by 4, I get a remainder of 0. It goes in evenly, right? 3.0. So since my remainder is 0, that's 1, so my answer here is -3. I to the 25th, if I divide 25 by 4, so 25 divided by 4, you get 6.25. My remainder is 0.25. So if my remainder is 0.25, my answer is I, because it's just got a remainder of 1, so I get I to the first power. 1/2 I to the 7. If I do 7, divide that by 4, I get 1.75. So that becomes -I, and then simplify, so -1/2 I. 42 divided by 4 is 10.5. All I care about is the remainder, so 0.5 is the same thing as saying squared, so I squared is -1. That's going really fast through this, so what you're going to do is you're going to divide the exponent by 4, look at your remainder, and use this chart. Whatever your remainder is becomes your new exponent. So if your new remainder, if it goes in evenly, you get 0, your answer is 1. If your remainder is 1, so 0.25, your answer is going to be I. If your remainder is 0.5, so 2, your remainder is 2 out of 4, so that's why it's 0.5, your answer is -1. If your remainder is 3, so 0.75 is your decimal, you get -I. So that's a quick way to evaluate powers of I. Operations with complex numbers. Multiplying complex numbers is identical. We are going to talk about adding, subtracting. Super important right here, I squared is equal to -1. So we're going to start with adding and subtracting. We're just going to collect like terms. Let's come back over here. I skipped this part. Take that off. So excuse me for that sidetrack. So you're simplifying square roots with a negative number. So the very first thing I'm going to do is I'm going to split this up into -1 times square root of 12. So now square root of 12 is what we've been doing. 4, 3, 2, 2. So I got a pair of 2's. So that would be 2 square root of 3. Square root of -1 is just I. So my answer here is going to be 2I square roots of 3. That I allows us to take the square root of negative numbers, which we previously have not been able to do. So same thing, I got 2 So what you can really do is put an I out there and then change that to a positive. That's the easiest way to do. You don't have to go through and write square root of negative 1 times the square root of that positive every time. Put an I out front, make it positive. So square root of 36 is 6, so I end up getting 12i. Now if I look at this, same thing. I got 1/3 I times the square root of 63. 63 is 9 times 7, so 3 and 3. So I got 1/3 I bring out that 3, square root of 7. 1/3 times 3 is just 1. So I squared of 7 is my solution here. Now with two negatives, you can do it two ways. You can keep it separately, or you can just multiply them together. I like to just keep them separately. So here, the square root of 16, that's I times the square root of 16. Then I got I squared of 49. So I'll show you both ways. I'll do the other one differently. So when I multiply this, I got square root of 16 is 4. I got the square root of 49 is 7. So 7 times 4 times I squared. So I get 28. I squared is equal to negative 1, so negative 28. And you are good to go. If you don't do it separately, you're not going to get the negative, so make sure you're doing that separately. And we're good to go. So here, I got I squared of 3. So that one's done. I got I squared of 121. Now, the square root of 121 is 11. So I got I squared of 3 times I 11. So everything's on the outside besides the square root of 3. So I got 11 I squared, square root of 3. So my answer here is negative 11 square roots of 3. So make sure you're pulling them out and you are good to go. All right, now just talk about that helpful hints. Bring out the I first. Then simplify. All right, let's take a look at some operations, which I tried to do earlier, but I didn't. That's my fault. So we're looking at this. Super important. Remember, I squared is equal to negative 1. So adding and subtracting, you are just combining the like terms. Sorry for that interruption. I paused it. Hopefully I didn't lose much. So combine the real parts together and combine the imaginary parts together. So when I'm looking at this one, my real parts do not have an I. So I got negative 2 plus 3 is just 1. My imaginary parts do have an I. So 4 minus 11 is negative 7, and it keeps the I. And you're done. Piece by piece. Now negatives, we're going to do what we always do. We're going to distribute that negative. So 4 minus I, and then I have a minus 5 minus 8i. And you're going to do the same thing. So 4 minus 5 is negative 1. Negative I minus 8i is negative 9i. And you're done. All right, this one I'm adding, so I'm just looking at like terms. So negative 3 is my only real unit. 5 plus 6 is 11. And I just keep the I like it would just be a variable. You just keep it along, and that's your imaginary part. And then this one, going to distribute the negative. So 2i minus 3. Negative times a negative makes that a positive 5i. Now we're going to combine like terms. So negative 3 is my only real part. 2 plus 5 gives me 7 i's, and we are good to go here. Multiplying. Big thing here, I squared is equal to negative 1. That's going to come into play a lot with multiplying. So I'm going to distribute these. So 2i times 3 is 6i. 2i times negative 5i is negative 10i squared. Now remember, I squared is equal to negative 1. So I got 6i minus 10 times negative 1. So 6i plus 10 becomes my answer. Write it in order. So 10 plus 6i. For B, I'm going to FOIL or use the box. It doesn't matter. So 5 times 4 is 20. Outside, negative 15i. Inside is negative 24i. Last becomes a positive 18i squared. So remember, I squared is equal to negative 1, so that becomes a negative 18. So now I can combine like terms. So 20 minus 18 is 2. Negative 15 minus 24 is negative 39 i's. And then C, 6 times 6 is 36. I got an I squared. I squared is equal to negative 1. So you end up getting negative 36. So nothing's really new in your strategies. Just remember when you're adding and subtracting, it's just like variables. You can only combine like terms. Your real numbers get added to your real numbers. Your imaginary numbers get added to your imaginary numbers. Multiplying, your biggest thing you got to remember is I squared is equal to negative 1, so you can simplify it down. When we come up to here, remember our patterns, it repeats every 4 times, so you divide your exponent by 4, and then look at your remainders. So make sure you know that chart very well. So go ahead, work through the practices, follow on eClass what we're supposed to do the rest of the day, and I hope you have a good one.